A lot of people test their Grasshopper definition at the very end. I think that's not the right move. What I do instead is test every chunk after I'm done with them. And in this video, I will walk you through exactly the steps that I'm taking to test my chunks to have a better and more efficient Grasshopper script. Many people keep building even they are not sure the last part is correct, front part is correct, first part is correct. And when they do this, they eventually get some kind of results. And if especially they're in rush, they rely on the things that they see, but that gives kind of a vulnerability, which is the small mistakes. And that those small mistakes can be hidden until the definition becomes more complex. By the end, it becomes hard to know where the real problem was, and this makes Grasshopper feel harder than it needs to be, because at the end of the day, you are trying to create the workflows that you'll be using next week, next day, next month, even next year, right? So instead, what I do, I build one small part of the system and then stop. Check if it's doing its job, then move on. I make sure, for instance, geometry is correct before moving on. I make sure these values behave the way I expect them. Again, then I move on. And then, only then, I continue. This also gives me a chance to keep things in control. So maybe chunk A is working, chunk B is working, but chunk C needed to be reworked so that I can keep building on it. So in this example, I'll create a canopy from repeated arched elements. So this is the recipe: create one line, copy the arc in the series, extract its weak point, create an arc based on the line, control the spacing between ribs, change the height of arcs, create a surface across ribs. So I have the same thing here. I have my line here, and maybe I can try to sketch this with my terrible sketching skills in Grasshopper. So as you see, the arc will go up and up and up, and then it will start to go back again here, back down again here. So we are going to create a surface along these lines. Okay. So again, it's not pretty, it's just really ugly sketch that I create to be able to see what kind of a surface that I will be having. So I can have the embarrassing sketch here as well as my second step, or like second big chunk. And let's start creating one line. So I'll be getting this curve in one curve. It's auto saving for a second. It's one curve. Then copy the line in series. So I'll be moving this line on X direction, right? And it's a series, so I'll grab a series component. And this kind of will be my first chunk, right? And I'll start with 0. Let's go with steps with 5 meters, maybe. We can always decrease this. And let's go with 10 for now. Again, if you don't like it, we can always go back to, I can fix it. So now we have this one. So this surface slightly too kind of wide. Now I have it. So this kind of copy the line in the series. So this is what I do in my first chunk. I group this, I pull out a scribble, and then type chunk 1, line, copy, add this to here. But again, before I move on, I know that if I have my curve, that curve is moved with a series, and that series is controlled by 2-meter intervals. And in my series, I have in total 12, how many lines I have? So in this series, I have 11 lines, which is this guy over here. The next thing, it says extract its midpoint. So what I can do, can grab the midpoint of this by having the curve middle, and I can add the start and the end points, okay? So to make this even a little easier, I grab this same curve, I'll connect here, copy this and paste it, connect the same output, put it here, okay? And now I have my curve end and start point. I have my curve middle points. This means if I get an arc 3-point component towards the end, I can connect this guy, and connect this guy to create my arcs. It's going to say nothing because they're all on the same line for now, right? Then create an arc based on the line. I did that, but it's not going to work right now. So control the spacing between ribs, which we already have. Change the height of the arcs. And how we can do that? We can make a cool adjustment here. What I can do, I can grab a graph mapper here to visually control the heights. And if I right click to this and say, let's say a Gaussian, or let's say Bezier, what we can do, we can have this kind of control points in the graph mapper itself to be able to move these midpoints. And how we do that? In order to be able to do that, what we can do, we need to first create a range of points. And that range will go between 0 and 1. So how many points I have? 11. I'll get a list length to understand this because I want to have the same steps that I'm having here to be able to use this range as an input for this guy. Okay, same step, like the same number, but in the range I get, as you see, 12 range because 12 information, 12 pieces in that range. Because imagine if you divide this line with 1, you have 2 pieces. So it does the same thing. It always adds 1 line or 1 piece, 1 line of information at the end. Therefore, I will come over here and say subtract, and I'll subtract this 1. This is really important, okay? And I'll be using this as another chunk right after I'm done with it. So domain is 0 between 0 and 1, which is correct. This is between 0 and 1. And you see now I have enough information here. Yet you see the values are changing between 0 and 1. However, I can remap this. The source is 0 to 1. The target can be, I don't know, maybe we can range this between not 0, but 1 meter to, since it's a canopy, 1 meter to 7.5 meters. So the maximum will be 7.5. And if I can keep this here, if I can move this points, okay, in Z direction, if I go to the vector tab and grab the Z component, these map values, as you see, is ranging between now, starting from 1, and it goes to 5 because we are not hitting the top portion of this, right? Connected here, see we have this guy, and if I create an arc 3-point, first point, third point, and the midpoint, and if I create a loft here, kind of canopy. But the thing is, when you play around with this, you started to see that your canopy shape will change. And if you take this and convert this into, I don't know, like some other thing, like ocean, you see, you have this guy, you can even have larger height, you can make this a bit shallower, sort of narrower, or shallower at the same time. You can use a sine curve here as well, okay, to have this canopy, and so on and so forth. But let's go back to our chunks. So since everything kind of works, what I did, I created this at once. And now I'll be dividing this into chunks so that I can remember when I have it. So what I can do, I can get this and then say with a scribble chunk 2, start, end point, and I can get another chunk here, midpoint extraction, chunk 3 point extraction. By the way, it would be better if I also make these guys another group inside of this one, and maybe I can add just a text here, not a chunk, but a text. Or click at, okay, so now it's still not there, but that's fine. Changing the height. Again, this is very important for us. And if you, by the way, if you go to my school community, if you want to get an access to this file free and get more information about how I create my Grasshopper definitions, how I teach them, join my school community for free with the link in description. The chunk 5 is going to be scribble surface here, okay? And if I go back to my Word doc, so this is what we create, and what we did is while we are doing it, check whether the base arc is correct, whether the copied arcs are spaced correctly with the series, number of reps, height variation based on the graph mapper, whether the final surface follows the rep logic clearly. And this is very helpful because it kind of makes mistakes become visible and earlier, and the definition becomes easier to trust, even if you spend more time by working on other things and then you come back and you'll see the mistakes. Debugging is a lot simpler, and everything turns into bits and pieces, which makes them manageable. And in short, Grasshopper becomes less overwhelming because you take a big problem and you divide it into smaller chunks and you execute on those chunks by using this system. So the main idea is not keeping building things blindly. Build a chunk, test it, see it, and then continue. If you are serious learning in Grasshopper, I have 5 one-on-one spots to work with me. Follow the link in description to book a discovery call with me so that we can see if I can help you along your journey. Thank you for watching this video, and I'll see you in the next one.